We show here a pipeline with a rectifier and an impressed current anode bed. I'm not showing the current flow off the anode bed here, but we also have a power line present, a house, and a well. So in this particular scenario, and a situation occurred that was exactly like this, current pickup on the utilities grounded neutral, the ground at the pole and at guy wires, could both pick up or discharge at that ground, but in this case we're looking at pickup. It could follow the grounded utility neutral to a residence. Remember, the customer's neutral is bonded to the utility neutral at the transformer. So now current can flow on the grounded neutral to the house, which is tied with the grounding conductor to the well and to the pump in the well. And now current can discharge off of the pump in the well, which is, of course, submerged in the electrolyte at great depth, so it actually may be a fairly decent path for current discharge to occur to go back to the pipe. In this case, and in many others similar to it, you have damage to the well pump and replacement of the pump at an early stage, much earlier than it should have been for the life of that well. Here's another case of interaction between power companies and, I'll say, not exactly CP systems, but an unintended action that does result in corrosion, and it still relates to a tie to the utility. But I'm changing the story. This is a bit of a different scenario than the earlier cases. Let's look at a municipal water well that has to do its function of supplying a high volume of water to the city. It will receive power from the utility, the same distribution line like we were looking at before. It has an incoming neutral with its service, let's presume. That neutral is grounded, and also tied to ground would be the submersible pump in the well. For safety, there would be this green wire, the grounding conductor. So that makes the well pump tied to the surface grounding system and also tied to the utility's neutral grounding system, which includes all of its pole grounds, other customers, etc. There's normal AC load current flowing to the various loads in the entire distribution system. The return current is expected to be, for those kinds of loads that involve a neutral, you'd expect that current to flow back on the neutral. But because grounded neutral systems are tied to lots of different structures, while the predominant return current is via the metallic neutral, there will be some current that flows via the pole grounds, or in the case of this well that we've tied in, it becomes part of the AC grounding system and AC return system. If that well is a particularly effective ground, it may receive a little bit more current and discharge and pickup, because AC is a bidirectional signal. It will have interaction with the soil perhaps to a greater degree than that ground rod up near the surface. It's a lower resistance path. In fact, current returning back to the source is going to follow all paths that are available. The predominant path, the lowest resistance, is probably the utility's grounded neutral, but there are other paths. So there could be an effect on a water well system, and this indeed has occurred, where there's premature death of a submersible pump and the bowl or the column because of corrosion. But it's probably a little bit different effect. Any of these systems could suffer corrosion, but chances are the surface grounding systems really are not going to have any notable effect for corrosion. But water wells themselves have had their pumps damaged. So if one was to solve this problem, you can't take the traditional approach of most pipelines and tank farms where you use a decoupling device. It would have to be a different device in this case because of the effects that we're actually experiencing. This would need to be an AC and DC blocking device. Normally we're concerned about blocking DC, but the trick in this case is it would also need to be effective at blocking AC so that the well is not part of the normal grounding system. Even though you didn't intend it to be a ground, it effectively is a ground. It would need to block that AC current. Now, why is that? Again, back to decouplers though. Normal decouplers, typical decouplers, block DC and they pass AC. And that allows them to accomplish useful functions like AC mitigation for induced AC on pipelines that are in a right-of-way with a power line. And they have continuity, so that you have AC continuity with DC isolation. But in this last story, if AC current is actually the problem, and the reason may be AC discharge off of these well components preventing a proper polarization film from forming that prevents corrosion in the first place, then the corrosion process can occur unabated and have very rapid deterioration of the pump components. If that's the case, we actually have to block AC current flow. And that's why this would require an AC and DC blocking device. So this is kind of a special twist on what's normal for decoupling of cathodically protected facilities. So treat this again as a special case. But it's interesting because it all comes from interaction with the power utility system. If there wasn't a tie to the power utility grounding system from an AC standpoint, then you wouldn't have the same effect. So in summary, because power utility systems are connected into the same electrolyte and are in the same geographical arrangement and area as cathodic protection systems that also use that same electrolyte, we're going to have interaction between the two. This is just a practical effect that occurs. Most of the time it doesn't cause excessive problems, but there can be orientations and sometimes non-obvious connections that cause utility system and CP system interaction, sometimes causing corrosion that is substantial. So consider if the arrangement, layout, possibly bonding, or the level of current that flows are a level of concern, and then take the needed action to do that. These can be confusing topics, so if you do have questions on this, you can contact Dairyland at the email address shown, and technicians can supply information on how you'd sort out electrical systems and cathodic protection systems. Thank you.